So trapezoids are the first quadrilateral that we're talking about that are not parallelograms, okay? So we've spent a long time sort of focusing on parallelograms and their subsets. So remember, big star, trapezoids are not parallelograms. They are quadrilaterals. So they are not going to inherit all of the things that parallelograms have, like both pairs of opposite sides being congruent, opposite angles being equal, diagonals bisecting each other. All of those things that we learned about that were true for parallelograms are not true for trapezoids. Trapezoids do not get them. They are not part of that family. They do have their own cool things that happen, but they are not parallelograms. They are quadrilaterals, so they do still have four sides and all the angles add to 360. That's still true, okay? So let's add that. They are quads, so their angles add to 360. And they have four sides, of course. All right, now let's refresh our memory. What even makes a trapezoid a trapezoid? What does it have to have? It has to have exactly one pair of parallel sides. It does not have both. If it's both, then it's a parallelogram. So trapezoids, exactly one pair of parallel sides. So I'll just say, remember, traps have exactly one pair of parallel sides. Oh. Give you a minute to jot that down. So what I want to do is sort of explore what's happening in a trapezoid and see if we can come up with some rules that will be true for trapezoids that aren't necessarily true for parallelograms. So what I'm going to do is I'm going to draw for you a parallelogram, but I'm going to do it in a weird way, okay? So I'm going to start by drawing a pair of parallel lines cut by two transversals, okay? So bear with me here. I'm going to have one line, and then I'm going to draw another line that's parallel to it. Okay, I'll even mark these lines as parallel so we know, yep, those really are parallel lines. Now I'm just going to cut these two parallel lines by two totally different transversals. So I'll do one like this, and then maybe I'll do one that's even kind of more slanty like this. Just make that a little bit darker. Okay, great. All right, so do you see what I made? Look how cute it is. Hold on, let me get one of my highlighter tools here. Let's go with orange. Ta-da! I made a trapezoid. See how there's a trapezoid in there? It has exactly one pair of parallel sides. Right? That top and bottom are part of those parallel lines. So they are definitely parallel to each other. So this thing that I have created and sort of highlighted in this orange shape, I've got a trapezoid. And all trapezoids in the whole wide world work this same way. If I just extended all the sides, I'd have a picture that kind of looks like this. Now, why is this important? Because you know something about the angles here. let me zoom in a little bit. If I told you that, oh, I don't know, let's say I told you that this angle right here was 110 degrees. Do you know any of the other angles in the trapezoid? Could you figure it out? So let me label the other two. You've got angles. Let's have an angle 1, an angle 2, and an angle 3. Could you find any one of those 3 angles if you knew that this one was 110 degrees? If you think you know one of the, or more, right? If you know any of the other 3, tell me. Think back to our parallel line chapter. What kinds of angles are these? And what has to be true about those angles?
That they add up to 360.
You're right. All 4 of them together are going to add to 360. Absolutely. Because you have a quadrilateral. You have a 4-sided figure. But if I only have 110, I can't find these other ones. I know that angles 1, 2, and 3 plus 110 is going to get me 360. That's true. But I can't really get much further than that without a little bit more information. There is, I'll tell you this, there is one angle in here that you can find right now before I ever even taught you about trapezoids. This goes back to the parallel line chapter. You used to do problems just like this. I'll give you an even bigger hint. It's angle 1. You know what angle 1 is. Or at least how to find it. Oh, I'm getting it in the chat. It is 70. Angle 1 is 70. What? How? Why? Don't forget all of your stuff that we learned about all those angles. These 2 angles right here, aren't they same side interiors? They are, right? Check it out. You have your transversal. They're on the same side, and they're both in between the other 2 lines. So same side interiors are supplementary, right? So that's how I know if this one's 110, that means that this one here has got to be 70. Now, so I'm going to change that from an angle 1 to a 70. Actually, I'll just make it look like this, 70. Yes, those 2 have to be supplementary. Now, as far as angles 2 and 3 go, I don't know what they are. All that I can say about them is that whatever they're going to be, they have to add to be 180 because they are another pair of same side interiors, right? Now, it doesn't work when you go sideways like this. These angles really have nothing to do with each other. Same thing here. If it's just a regular old trapezoid, there's nothing that's going on there. These 2 angles will always have to be supplementary, and these 2 angles will always have to be supplementary. Okay, but it could be completely different from these. So you'd have to have one of the other 2 angles. So I don't know, maybe I tell you that angle 2 is, I don't know, 30 degrees. So I'd have to, let me switch colors here so we don't get all confused. So if this one happened to be 30, now you could find angle 3. What would angle 3 have to be? Will I let James in? Okay, let's go back here. I gotta find where that attendance is. I'm sure it's gonna make me restart my camera too. James.
Sorry.
I'd rather you late than never. Oh shoot! Now I gotta log back
I had
in.
to complete a test. So.
Just what you want to do on a Tuesday morning, right?
Mm-hmm.
Oh, God. Why can't I find this? All right, James, not that one. All right, let's see if my camera is still operational. I'm going to guess no. Yeah, no, it's just frozen. Okay. Maybe if I just re-click it, does that work? Oh, it worked. Okay. All right, so anyway, if this is 30, you should now be able to tell me this one. Oh, yes, I got a couple in the chat, but hopefully if you didn't do it yet, you get it real quick. Yes, 150 would have to be. So we need to make a big note that what's going to happen is that along these two transversals, so the two sides that are not parallel, so if you follow the two angles on one of those sides that's not parallel, here and here, you're always going to get a pair of supplementary angles. Notice that if you go across, right, these two angles really have nothing to do with each other. 110 and 150, nothing to do with each other here. 70 and 30, nothing to do with each other here. So those could be totally random. So I can't really rely on that. Yes, you're right. All four do have to add up to be 360. That will always be true. But if I just give you one angle, so let me just draw you another trapezoid. So say you had something even like this. Right? If I only give you one angle, you could only find one other one. You couldn't find all four. So let's try it. If I told you, let's be fancy. What if I told you this one was 90? Out of your other angles, 1, 2, and 3, what other one do you know, and what is it? So in this picture, what other angle do you know, and what is it? Yes, it's going to be angle 3 is going to be 90 because these two will be supplementary. So if that's 90, that means this one also has to be 90. But it really has nothing to do with these two. All I know is that angles 1 and 2 are going to add up to be 180 also, but I don't know what they are. They could be anything as long as they add to 180, okay? So let's put a big star in our notes and sort of dictate that in trapezoid, you're going to have these two pairs of angles that are supplementary, but that's different from a parallelogram, because remember in a parallelogram, we said any two pairs were supplementary. So you could go sideways in a parallelogram, but you can't do it in a trapezoid. It's only going to be these two and these two. All right, so let's get that down in words, because that's super important. Okay, so let's say big star. All trapezoids have two pairs of supplementary angles. I'm going to say along the non-parallel sides. And we'll draw a picture so you have a nice visual of what that means in words. So just draw yourself any old trapezoid. And then you just want to note to yourself, I'll put angles in here, 1, 2, 3, and 4. You're going to have, so I'm going to This is what because remember, not every trapezoid is positioned this way with the parallel lines on top and bottom. It could be on its side. It could be, tilted some weird way. So one thing you could do is you could always just turn your paper so that it is on top and bottom. But you just find the sides that are not parallel. Okay, so this side isn't parallel. So the two angles that run along this side, these are going to be supplementary. And then you have your other two along the other leg that are not parallel. Those two are supplementary. So I don't know if you remember, but in when we were doing parallelograms, I could give you one angle and you could find all of the other ones. You can't do that with a trapezoid. If I give you one angle, you can only find one other one. And then I'd have to give you something for the others. Okay, any questions so far? Are we okay with this? So far, so good? Okay, so let's do, I'm going to throw some algebra in here. I got to turn the page, so give you just another second or two to jot this down if you need to. Does anybody ever go to the drive where I post all the notes? Does anybody use that? Or am I doing that for no reason?
I use it.
You do? Okay. It's not a big deal for me. I'm just... Oh, I'm sorry. Say that again.
I said I use it sometimes when I'm missing notes.
Good. Yes. And I just feel like if you do have to be absent for some reason, I imagine it would be helpful. But it's okay if you don't. I mean, I could never. If I were a student, I could never use someone else's notes. I have to do it my way. You know what I mean? I don't know. I'm that person. I can't. It wouldn't work for me. I'd hate it. So even you, you don't have to copy it down like exactly how I have it. If it makes more sense. Like I've seen kids do. Some people are way more organized than me, and they have like key terms on one side, and they put definitions on another side, or they have they only put diagrams in one section, and then they have words in another section. Whatever works for you. I don't care, as long because it's your notes. I do want you to write something down, but okay. So, any Hoosers, we're here. I am going to give you. Let's throw a little algebra in here and see how we do. What pen was I using? This one works. Okay. Some people get real fancy with their notes. They have like a table of contents, and I do highly recommend though, if you are considering going off to some sort of, if you're going to continue your education past high, or even in high school, I don't know, I think it would be useful. I use this, let me just show you real quick. This is my fancy notebook. I know some of you I've already talked about it. It's called the Rocket Notebook, Rocket Book, yeah. Have I told you about this before? I feel like if you've had me before, I mentioned it because I was all excited when I got it. The pages are like plastic. And you write on them with just these, they're kind of normal pens, but they're these Frixion pens. It'll say Frixion on it. Frixion? I don't know how to say it, but you write on it with those. And there's all different kinds of pens. They're not super expensive. It's a little bit more expensive than just your regular pen, but they're not crazy. I don't know. I just buy them when they're on sale. Anyway, so you write on these pages that are like plastic, but then at the bottom, see there's a QR code? So that's how I post your notes. There's an app, and you just scan each page, and it's super fast, and it just uploads it to wherever you want. So you guys, I make this mark at the bottom, and when I make that mark at the bottom, it knows to send it to your class's Google Drive. So for C block, I mark a different box and it sends it to their Google Drive. So if I were a student and I needed my notes and I wanted to have that, like, be able to, organize them and look back on them, whatever, you could have just a symbol for each of your different classes. And what's so cool about this is, so that's why I put those hashtag marks around the titles. When you do that, it automatically like titles the file that, so you can just search for it later. I don't know how much this would have been so useful when I was in school. My God, I'm just thinking of my zoology class. I could have just searched anything instead of just trying to flip and find it. Oh, so I highly recommend that you get yourself one of these, and because it'll last you forever. Because the pages are plastic, so when you're done, you just wipe it down with like a wet paper towel, and it just goes away. And then you could just use it again and again and again and again forever. And if you scanned it, you have a copy of your notes forever. It's so useful. And you're saving the planet. Look at that. There are other ones that you can use to clean it. You put it in the microwave. And you microwave the whole notebook. I don't have one of those. But anyway, I get super excited about my notebooks. All right, so here's a trapezoid. We were going to throw some algebra into this. So tell me if, I don't know, let's say this down here was x plus 20. And let's say this was 2x minus 10. Could you write an equation that solves for x? Go ahead, do it. Write yourself an equation that solves for x and figure out what x is. Olivia, the equation is perfect. Feel free to send me your answer for x when you've got it. Hopefully everybody has come up with the equation by now. Those two angles together must add to 180. They're going to be supplementary. So that is my equation here, right? Because I have a pair of angles along one of the non-parallel sides. So that's how I know that they're going to be supplementary. And now I just solved this equation. So I get 2x and x is 3x. Negative 10 and 20 is a positive 10 together. Oh, I'm sorry. I didn't realize that this didn't come out nice. Whoops. But you know what? In life, it doesn't always come out nice. Sometimes things get a little messy. So let's ask Mr. Calculator what 170 divided by 3 is. 56.6 repeating. So if we rounded that, we'd get 56.7. Oh, sorry, Olivia. I didn't. Sorry. Okay, so any questions so far? Because now we're going to talk about isosceles trapezoids specifically. And they kind of follow different rules. Different rules. But you might already know some of them. I don't know. Let's see. So I'm going to divide my paper up here. So these are specifically isosceles trapezoids. All right. So first of all, let's remember what they even are. If you have isosceles trapezoids, remember those are the ones that look like this. They're still going to be a trapezoid. They're still only going to have one pair of parallel sides. But the difference with the isosceles trapezoids is that those legs are going to be congruent to each other. And I think we did already mention something about the angles with them. I feel like we did, or maybe we didn't. I don't know. I can't remember now. So I'll just ask it this way and I'll see if you know. If this happens to be 70 degrees, you still have these three other angles in here. Do you know what they are? What the measures of any of these other three angles is going to be?
2 is going to be 70, right?
That would be true if this were a parallelogram. Did you say 2 was going to be 70? So someone else is going to be 70, but it's not 2. It is, Olivia's got it here, 3. Angle 3 is going to be 70. So here's what we want to remember with isosceles. So let me just go back to a triangle real quick. Remember in the isosceles triangle, when you had two sides the same, remember it pointed at the two angles that were going to be the same? You had these two base angles that would always be the same. Remember that? So if you had two sides the same, you have two angles the same. The same thing applies to the isosceles trapezoid. So those two marks are going to point at the ones that are going to be the same. So yes, these two are the same. You still have base angles being congruent. So angle 3 is still 70. Or is also going to be 70, I should say. Now I can find angles 1 and 2. Because remember, this is still a trapezoid, so I still have this pair of angles that has to be supplementary. Same thing's happening over here. This pair has to be supplementary. So that means angles 1 and 2 are also going to be the same, and they're both going to be 110. So I get 110 for this one and 110 for this one. So, oh, that looks like a 40. That's not what I mean at all. It should be 110. By the way, I just realized I didn't tell you about the cost of the notebook. They're not even that bad. They're like, I got mine on sale. I think it was like $20 on Amazon. But then you never, like I've been using this one same notebook for, I don't know, 3 years? 3 years, I think. So I would agree that $20 for one notebook seems like a lot, but if it's literally the only notebook that you need to buy, I think it's pretty convenient. So anyway, I wish I got like an affiliate fee, but let's try another one. What if you had, now you got to be careful because you got to make sure that these are in fact isosceles trapezoids, because if they're not, then the only thing you can do is what we were just doing and have the two pairs that are going to be supplementary. So let's say this time I told you that this angle was 120. Could you find all the others? Go ahead, real quick. Find me all of the others. Olivia, that's right. Give everybody one more minute to get an answer. Okay, so let's see. I don't know. You could start really wherever you want. I'll start with angle 3 because these two, whether it's an isosceles trapezoid or not, these two are going to have to be supplementary. So if that one's 120, that means this one's got to be 60. Okay, perfect. Now, if this were a regular trapezoid, I wouldn't be able to go any further. But because it is isosceles, right? Because I have those two legs the same, that's telling me, hey, you're going to have these base angles that are the same. So this angle and this angle are going to match. So now I know, okay, angle 2 also has to be 60, and the same thing is happening up top, right? Those two angles are also going to be the same. So angle 1 will be the same as this one over here, angle 120. So, yep, angle 1's 120, and then 2 and 3 are both 60. All right, I'm going to do 1 with a little bit of algebra, see how you do with that. And then we'll talk about the last fun fact about isosceles trapezoids. I'm going to stick it over here. Whoa. You know what? I'm going to try and confuse you too. See if you can handle this. Oh, wait. What am I doing? I'm supposed to give you an isosceles trapezoid. Ay, ay, ay. I tell you. It's okay. We'll make it happen. Sorry. Okay, there we go. And then we'll mark it as isosceles. So now let's try this. Let me zoom out a bit. You have an isosceles trapezoid. Try and answer this question. Can you write an equation and solve for x here? Try it. Those are the two angles. So 2x plus 10 is this angle, and 3x minus 7 is this angle. Oh, it kind of looks like a negative. It's not supposed to be. It's just 3x. Just 3x minus 7. Okay, you've got those two angles. Olivia, that equation is correct. Go ahead and solve it and see if you get an answer that makes sense. Elizabeth, can you send me what your equation was? Here, that's right. So, okay. I'm getting a few of you answering 35.4. Here's the thing, right? So I tricked you. I'm going to, if I turn my paper around, so it kind of looks like the trapezoids that we've been looking at, it's a little bit easier to see it here. These two angles are the ones that are going to be supplementary. These two angles would be supplementary. What's happening when you go across the parallel line like you have here? If you have an isosceles trapezoid, these two angles are going to be equal to each other. Just like these two bottom ones, this little one here and this little one here, those would be equal to each other. So you can go across the parallel lines if you have an isosceles trapezoid. And since this is, that means these top angles are going to be equal and these bottom angles would be equal. They're not supplementary here. It's the ones that go along the legs. Along the legs is supplementary. Across is going to be equal. For isosceles trapezoids, because in a regular trapezoid, you can't go across. They kind of have nothing to do with each other. But if it's isosceles, you get these cool properties and you can actually do it. So then I tried to trick you by turning it on its side. So be careful. I actually want to set these two angles equal to each other. 2x plus 10 should equal 3x minus 7. And then you can go ahead and so, Olivia, you are done. You gave me an answer, didn't you? Yeah, you're the first one that gave me the answer. I'm confused because you did it out already. I'll wait a minute, but you already have your... Oh, you're finding the measure of the angles. Yeah, I don't know what they are. But that sounds right. Haley, that's right now. Yeah. Okay, so I'm just going to solve this real quick. I'd minus that 2x. And then add that 7. So yes, if you got 17, you're spot on. Okay, be careful. Remember that you can always take 17 and plug it back in and make sure that the angles make sense. They should be equal to each other. They look like they're equal to each other. They're both these big obtuse angles. So whatever answer you get, pop it back in. And if they're not the same, something's wrong. Something's not making sense. Okay, so let's kind of put that in words just so that we have this sort of cemented in our notes. I'm going to put it right here. Isosceles trapezoids have two pairs of angles that are congruent. Okay, that's special to the isosceles. Oh, for the love, look at how bad that line is. That's the other thing about this notebook and these pens, they're erasable. So all the pens that you write with, you can just erase the pen. And they have highlighters and all the things. Okay, so in my isosceles trapezoid, you're always going to have these two pairs being the same. So I'll just number the angles real quick. 1, 2, 3, and 4. You will always have these two angles up top being the same, and then these two angles at the bottom being the same. It is still true that these two are going to be supplementary and these two are going to be supplementary. So now for the first time in a trapezoid, if it's isosceles, I can give you just one angle and you can find all of the others. You cannot do that in a regular trapezoid. You can only find one other. Okay, and then the only last fun fact about the isosceles trapezoid is, you ready for this? They also have congruent diagonals. Think about it. Doesn't it make sense? Look at this picture. Wouldn't it make sense that this distance would be the same as this distance? Right? It's got to be, because you are basically taking an isosceles trapezoid and like cutting the head off. Right? If this just kept going, it would just make an isosceles trapezoid. So we're just going to evenly cut it off so it's perfectly horizontal to the bottom. So yeah, it makes sense that these corners would have to match up if these two are going to be the same and all these angles have to match. So this, you have a pair of diagonals that's congruent. And I know I kept saying that rectangles are the only ones that have that. They're the only parallelogram that has that. Okay, you can have other shapes that have congruent diagonals, such as the isosceles trapezoid. All right, so big star Another big star. We had a lot of big stars today. Isosceles trapezoids also have congruent diagonals. They are not going to be perpendicular. They are not going to bisect each other, but they will be congruent. So let's see if I can draw you one without going on to another page. So here I have my isosceles trapezoid. We'll mark it so that we know that it is so. And then I'm going to draw them in. I'll draw it in with red as best I can. That's pretty good. Okay, so if you look closely, you can tell that they are not bisecting each other, right? I definitely have this a small piece and then a long piece. So those two parts are not equal to each other, right? The pieces of the diagonal. However, what is true is that the whole thing here is going to equal the whole thing here. You get that. But as far as these smaller little parts go, those aren't the same. It is true that these little pieces, so this little piece would actually match up with this little piece. And then those longer bottom parts, those would match up with each other. So you have this part that would match up with this part. But really, that just means the length of the whole thing has to match up with the length of the other whole thing. And that's the best I can do. So notice they do not bisect each other. That's kind of a big deal. That only happens in parallelograms. Okay? Only. Nobody else has diagonals that bisect each other besides parallelograms. Okay. Does anybody have any questions right now? All right, so I am going to, I think that's it for the notes here. See, I'm gonna mark your symbol. I don't know if you guys can see it, but you are the, let me zoom in so you can see. So when you download the app, oh, you can't see it at all, can you? Oh, there it kind of is. When you download the, oh, see it? It's like an arrow shape for you. I don't know. But anyway, on the bottom, there's like 7 different locations that you can designate. So if I just mark it on here, when I scan this page in the app, since I marked it on that spot, it knows to just go send it to B-Block's Google Drive. That's so cool. Anyway. All right, the homework. Where is it? It is... Oh, it's on CUDA today. So let me go make it live for you. I think I had already pulled it up because I was playing around with it. There's your Fast 5. We're done with that. And, oh, okay. This is going to be homework number 22. Trapezoids. All right, let me make this live. B-Block. All right, so it is now live for you. I will do a few of them if anybody feels like they need it. If you don't, then just go right for it.
On CUDA, right?
Yes, make sure you hit refresh. Homework 22. All right, so you're just going to start off with trapezoids. Remember that along the sides that are not parallel, those are just going to be supplementary. So if that's 80, that one's 100, right? So again, oh, that's funny. There's another one that just so happens to be the same. They won't all be the same. Here we go. Here's one along the sides that are not parallel. Those have to be supplementary. So that should be a pretty easy, those should be quick. So fast forward. Now take a look at this. Now you have encountered an isosceles trapezoid. So remember, those base angles are going to be the same. So if this one's 70, that means this one over here will also be 70. Be careful, because they could just as easily ask you for, oh, look at this one. I like this one. I'll actually write on it over here. So if I'm doing this one, I'm like, oh, okay, well, this one is an isosceles trapezoid. So that means if this angle's 125, that means this one is also 125, because they're going to match. So I know that you're 125. Now it's still a trapezoid though, right? So along the sides that are not parallel, so these two angles would be supplementary. These two angles would be supplementary. So that's how I can go ahead and solve for this one. If I know that one's 125, whatever 180 minus 125 is would get me that missing one. Okay, so be careful. Always make sure you're answering for the correct one. This one's the exact same, it's just different numbers. So fast forward. Okay, now you've got some diagonal questions. Notice that these are isosceles trapezoids. If GE is 10.1, I'm supposed to find FD. Well, if that whole thing is 10.1, isn't this whole thing 10.1? Because they're the same, right? The diagonals are equal. So if they gave me the whole thing, they're just equal. So that's pretty easy. So let's see, are there any trickier ones? No, that's easy. Yeah, so you're going to have a bunch in here that are, you should be very excited when you get to that section, because you're like, oh, those are super easy. A little bit of algebra. This is not an isosceles trapezoid. This is just regular. But it doesn't matter, because in every trapezoid, this is always true. Along the non-parallel sides, those two have to be supplementary. So just write your equation. 3x plus 103 plus another 77 would have to equal 180. There's your equation. You just solve it, and you should get your answer for x. Okay. Oh, be careful. Yeah, so here now, this is an isosceles trapezoid. So stop and think. Are these two angles equal, or are they supplementary? Well, remember that in an isosceles trapezoid, you have these two pairs of angles that are going to be equal. Those two would be the same, and these two down here would be the same. Right? So those two base angles are equal. It's only when you go along the non-parallel sides, those two angles would add up to be 180. But that's not what I'm doing here. Same thing over here. These two would add up to be 180, but I don't care about those. I'm caring about side to side, and the only way to do that is to set those two equal to each other. All right? So be careful. Slow down. Don't go super fast. Oh, and that's it. All right, so see how far you can get before class is over. I do have a question for you guys. Does everybody know, all of a sudden this started happening, when I'm writing, see how it's like showing my name? How do I make it stop doing that? I mean,
No
it is...
idea.
No idea. I don't know either. And I don't know why it started. I don't know if Zoom did an update that I didn't realize. It would be convenient because there was a few times that other kids were writing. And I don't know if that was this class or not. And I'd have to say, stop writing. And I didn't know who they were. So now I would at least know who they are. But I don't want, because every time I'm writing, that's so annoying to have my name here. There's got to be a...
Do you know if it just shows your name?
I don't know. Try and write on the screen, can you?
Yeah. Hey, it shows my name.
Olivia says, you see that icon near it. Near what? I have like the toolbar where I pick like pen. I can change the color. I can erase. And that. It's got to be, I feel like it's got to be a setting in the, oh, it looks like an eye. Oh. Let me see. Okay, let's look on the, it's got to be on the host one, right? So here I am looking at my Chromebook that has a host. It looks like an eye, but there's a,
I finished. Can I leave?
yeah, I guess.
Okay. Thank you.